Now we're going to continue again looking at ultimately a non-right angle triangle. And we're going to look at a new rule, which is the cosine rule. So again, we'll set up our triangle. Remember, we work in opposites, so there's the angle C. Opposite that would be the side C, side B, and then the side A. Okay, so there's another rule that can help us with non-right angle triangles, and that is the cosine rule. Okay, so cosine rule. And what that will tell us is ultimately, if we take the cosine of any of the angles, so let's say the cosine of A, it will equal side B squared plus the side C squared minus the side A squared, all divided by 2BC. Okay? So, what is that telling us? Well, it's telling us we can get an angle through a combination of the sides. Okay? And it's very important how the angle is made up. Okay? If we're looking for the cos of A, so the cos of A, there's the angle A made up. And it's made up by these two sides here, side B and side C. Okay? So they become the two positive, and then you take the opposite side, you subtract it, and then you divide by 2 times those two sides that make up the angle. Okay, so the cosine is used with the sides that make up the angle. So likewise, you know, we could have the cosine, say, of B. Now with B, it's going to be sides C and A that make it up. So they're going to be the ones that get positively squared, and it's going to be minus the side opposite, which is going to be B, and then 2AC. Okay, and again we could do that for the cosine of C, which would be B squared plus A squared minus C squared all over 2BA or AB. Okay, so it's important you know how to develop the cosine formula, because obviously your triangle is going to change shape and there's going to be different letters, so you can't just depend on learning off the formula. Ultimately, whatever it's cosine of an angle, you take the two sides that make up the angle, they become the positive squares, you subtract the angle opposite of it, and you divide by these two times the two sides that make up the angle, and that gives you the cosine rule. Now we can ultimately manipulate the cosine rule so that instead of just looking for an angle, we can look for one of the sides. Okay, so say we were given the angle A and we wanted to find ultimately the two if we're given the angle A and we're given the two sides that make it up, we could find the other side opposite to it, say, for an example. And what that will do is you go through a manipulation. Okay, and I'll not probably go through the whole manipulation, but ultimately it'll come out that A squared will equal B squared plus C squared minus 2BC cosine of A. Okay, sorry. So you can get that new formula through manipulation. Okay, your standard rules of manipulation, we can manipulate that, and then ultimately you can find A would be the square root of B squared plus C squared minus 2BC cosine of A. So the cosine rule is not only just brilliant for finding the angle when you're given all three sides, you can also find another side if you're given the two sides and an angle. Okay, it could be very useful. So that's the cosine rule. If we wanted to just run through a quick example of how we would use it, let's say we take our triangle, we're told A equals 11 meters, B says 13 meters, C 9 meters, and we wanted to find the angle A. Okay, The angle A is going to be made up through the sides B and C. Okay, remember that. The angle A is going to be made up through the sides B and C. So we want to find the cosine of A is going to equal 13 squared plus 9 squared minus 11 squared divided by 2 by 13, sorry, 9. Okay, so the cosine of A will equal something, so then ultimately A is going to equal the inverse cosine of 13 squared plus 9 squared minus 11 squared, all divided by 2 times 13 by 9. Put that in a calculator, you'd get your value for A. So that is the cosine rule. You know, super useful when it comes to solving non-right angle triangles. Now the cosine rule and the sine rule can be used on right angle triangles, but ultimately it's much easier to use SOHCAHTOA, so just stick with that. If we're doing right angle triangles, we're using SOHCAHTOA and Pythagoras. If we're using non-right angle triangles, we're using cosine rule and sine rule. Okay, remember SOHCAHTOA and Pythagoras theorem can't be used, so cannot be used on non-right angle triangles. So it's good just to have them separate rules to keep in your head, right? What are we dealing with? Are we dealing with a right angle triangle, or are we dealing with a non-right angle triangle? And then you know which rules you can apply. Some general rules as well is just for the area of a triangle. So we know, just to kind of throw this in here, we know we can get the area of a triangle by half times the base times the perpendicular height. Okay, that's one that kind of everyone really knows, but sometimes it's not always obvious, or it's not always possible to give this perpendicular height. So we can get another way of getting the area of a triangle, and ultimately it's a half times AB sine C. Okay, and again, if you have a triangle, and this is your angle C, this is going to be A, this is going to be B, it's going to be your side C. Okay, so again, you kind of have that setup where it's the two sides that make up that angle will give you your formula for the area of a triangle. Okay, so if you wanted to, you know, change that around, say you wanted to get the area of a triangle using other sides, so say a half BC. Okay, so there's B and C, and that would be the angle A because it's opposite the side A. So you'd have half BC sine A. And then finally, if you wanted to get the area of a triangle using the remaining ones, it would be a half AC. And ultimately, so A and C would make up the angle B because that's opposite the side B. There it is there. Now the area of a triangle, that can be used on any triangle, and the same way that A plus B plus C, all the angles in a triangle will add up to 180 degrees. That's for any triangle. But again, for non-right angle triangles, you're going to have the sine and the cosine rule.